Welcome to Section 10. More programs too. We start with a string manipulation technique, reversing a string. 1. Reviewing string slicing. Recall that string slicing uses the format square bracket start colon and colon step square bracket. We use the first two arguments to extract substrings. The third argument, step, controls the direction and size of the jump. 2. Reversing with step -1. To reverse an entire string, we use the special slicing syntax, ::-1. The first two arguments, start and end, are omitted, which defaults them to the beginning and the end of the string, respectively. By setting the step to -1, Python iterates through the string backwards. Three. The traditional approach. For comparison, achieving the same result using a traditional for loop is much more verbose. It requires initializing an empty string and concatenating characters from the original string in reverse order. While functional, it is less readable than slicing. To summarize, string slicing with the step of -1 is a practice for reversing strings in Python. It's concise, readable, and faster than manually writing a loop. Our next lecture 10.02. Reverse using split and join. See you there. Welcome back. In the previous lecture, we used string slicing to reverse the characters of a string. Here, we explore another method that uses three core tools: the string method split, the list slicing technique, and the string method join. This method may be used when the string is composed of separate words. 1. Splitting the string. First, we need to convert the string into a list of individual characters. We do this by calling the list constructor directly on the string. This breaks the string into its constituent characters, each becoming a separate element in a new list. 2. Reversing the list. Once we have the characters in a list, we can use the same slicing technique we learned previously, the ::-1, to reverse the order of the items in the list. 3. Joining the characters. The final step is to convert the list of reverse characters back into a single string. We use the join method, specifying an empty string as the delimiter. The empty delimiter ensures no spaces or other characters are inserted between the rejoined letters. To summarize, the split reverse join pattern is slightly more complex than direct slicing, but it provides a flexible framework that is crucial when you need to perform other list operations, like sorting or filtering, before putting the string back together. Now that we can reverse characters, let's look at reversing the order of words in a sentence, not the characters themselves. Join me in Lecture 10.03. Reverse the words in a string. Welcome back. We've learned how to reverse characters. Now, let's reverse the order of words in a sentence. This is a crucial distinction. We want the first word to become the last, and the last word to become the first. This is a job for the string split, list slicing, and string join methods. 1. Splitting the sentence into words. We start with a sentence. To treat words as individual elements, we use the string's split method. When called without arguments, split automatically uses spaces as delimiters and returns a list of words. 2. Reversing the word list. Once the sentence is a list of words, we can use the quick and clean slicing technique, ::-1, to reverse the order of those words in the list. 3. Joining the words back. The last step is combining the words back into a single string. This time, we must use a space character as the delimiter inside the join method to ensure that the words in the resulting sentence are separated correctly. To summarize, the key takeaway is recognizing that the split method converts a sentence into a list of words, allowing us to use list tools like slicing to reorder the words before finally reassembling the sentence with join. Our next lecture 10.04. Reverse the characters in the words. See you there. Welcome back. This program is in test of your string and list manipulation skills. Our goal is to take a sentence, reverse the characters within each word, just like we did with slicing, but keep the original order of the words in the sentence. This requires a 3-step process: split, process with a loop, and join. 1. Split and setup. We start by defining our sentence. The first step is to use the split method to break the sentence into a list of individual words. We also initialize an empty list processed_words to store our reversed words. 2. The loop and slicing. We iterate through the list of words using a for loop. Inside the loop, for each individual word, we apply the slicing technique, ::1, to reverse its characters. This reversed word is then appended to our processed_words list. Three. Reassembling the sentence. Finally, we use the join method with a space delimiter to turn the list of reversed words back into a complete sentence. The resulting string has the word order preserved, but the internal characters of each word are backwards. To summarize, the pattern of separating, processing elements individually, and then reassembling is fundamental to many complex data manipulation tasks. Our next lecture 10.05. Remove duplicate chars. See you there. Welcome back. Our next program focuses on data cleanup within strings, removing duplicate characters. This is an exercise that reinforces our understanding of iteration and the in-membership operator. We will iterate through a string and build a new result string, only adding characters that haven't been seen before. 1. Initialization and setup. We start with our input string, which contains repeated characters. The core of this solution is the empty string, unique_chars, which will serve as both our result and our historical record of characters already added. 2. Iteration and conditional check. We use a for loop to process every character in the input string. Inside the loop, we use the conditional if character not in unique characters. If this condition is true, it means we have encountered this character for the first time, and we should append it to our result string. 3. The alternative sets. While the manual loop is great for practice, there's a way to remove duplicates is by converting the string to a set. Sets automatically store only unique elements. We then join the unique elements back into a string, though this method does not preserve the original order. To summarize, the manual looping method is crucial for preserving the order of first appearance. It is a fundamental pattern for building a filtered collection by checking against the collection itself. Our next lecture 10.06. Count the characters. See you there. Welcome back. Our next program is focused on frequency analysis, counting how many times each character appears in a given string. This task is suited for using a dictionary, where each unique character will be a key, and its count will be the value. 1. Initialization with the dictionary. We start with our input string. There's a way to track counts, which is by initializing an empty dictionary. This dictionary, char_counts, will map characters to their numerical frequencies. 2. Iteration and counting logic. We loop through every character in the input string. For each character, we use the dictionary's get method. About this method, it safely retrieves the current count, and if the character is not found, it conveniently returns 0. We then add 1 to this value and update the dictionary. Three. Result and analysis. After the loop completes, the dictionary contains the final frequency of every character. Notice how the dictionary automatically handles case sensitivity. For example, a lowercase s is treated separately from an uppercase s unless you convert the entire string to one case first. To summarize, character counting is a skill for text analysis, and the dictionary get method is a readable way to implement this frequency counting logic in Python. Our next lecture 10.07. Print right-angled triangle. See you there. Welcome back. This program is to print a right-angled triangle pattern made of asterisks. 1. Understanding nested loops for patterns. Pattern printing requires 2 loops. The outer loop controls the number of rows, or the height of the pattern. The inner loop controls the number of elements, or the width, printed in each specific row. 2. The right-angled logic. For a right-angled triangle, the number of asterisks printed in any row must equal the current row number plus 1. Since the outer loop variable I goes from 0 to 4, the inner loop needs to run from 0 up to, but not including I plus 1. 3. Analyzing the output. When I is 0, the inner loop runs once. When I is 1, the inner loop runs twice. This continuous growth ensures the staircase shape of the right-angled triangle is formed. Notice the use of the end argument in the inner print statement to prevent a new line until the row is finished. To summarize, the fundamental principle of pattern printing is that the inner loop's range is dynamically dependent on the current iteration of the outer loop. For a right-angled triangle, the inner loop runs I plus 1 times. Our next lecture 10.08. Print pyramid pattern. See you there. Welcome back. Building on the right-angled triangle, we now face the challenge of creating a symmetric pyramid pattern. This is more work because it requires 3 distinct steps inside our outer loop: printing leading spaces for alignment, printing the pattern elements, and then moving to the next line. 1. Outer loop and space calculation. As always, the outer loop controls the rows. For a pyramid, the number of leading spaces needed decreases with each row. If the total height is 5, the first row needs 4 spaces. The number of spaces is always equal to the total height minus the current row index, -1. 2. Printing the elements. The number of asterisks increases in each row. The number of elements in a symmetric pyramid follows the pattern: 1, 3, 5, 7, and so on. This is equivalent to 2 times the row index I plus 1. We use a second inner loop to print the correct number of elements. 3. Analyzing the flow. When I is 0, we print 4 spaces and 1 asterisk. When I is 1, we print 3 spaces and 3 asterisks. This continuous adjustment between spaces and elements is what creates the perfect centered pyramid shape. To summarize, the pyramid pattern is solved by decoupling the printing process into loops dedicated purely to spaces for alignment and loops dedicated purely to the pattern elements. We created a pyramid. Our next lecture 10.09. Find substrings in a given string. See you there. Welcome back. This is our final program for this section, and this problem is about finding every possible contiguous substring within a given string. This requires us to use nested loops to control both the starting and ending positions of the slice. 1. Setup and outer loop. We start with our input string. The outer loop, using variable I, iterates from the start index 0 up to the end of the string. This loop defines the starting index for every potential substring. 2. Inner loop and slicing. The inner loop, using variable j, defines the ending index. This loop must start one position after I and continue to the length of the string plus 1. Why plus 1? Because string slicing is exclusive of the end index, and we want to include the last character. We then use string slicing to extract the substring. 3. Trace and output. Let us trace the first iteration. When I is 0, the inner loop j runs for 1, 2, and 3. This yields the substrings UB and ABC. When I is 1, the inner loop j runs for 2 and 3, yielding B and BC, and so on. To summarize, finding substrings is all about defining the correct start and end indices dynamically using nested loops and then leveraging Python's string slicing. Congratulations on completing section 10. Okay, we are going to next section 11. Command line arguments. The first lecture is 11.01. Introduction. See you there.